This is what I use to provide power to the electronic part of the solar oven controller. I use 4 18650 lithium-ion batteries. There are 2 sets connected in series and then in parallel, so I get a between 7.4 and 8 volts at really high power, 8,000 milliamp hours total. I have a small jack that I use which plugs into the side of the control box. And these are lithium-ion batteries. I have a small solar charger that I use to recharge these, so everything is independent. I could have put perhaps a solar collector on the oven control, but I wanted to have real reliable power, so I decided to take this approach. This is the control box that holds the electronics. It has an on-off switch, a program run switch. The program switch is selected when I want to program the temperature for the oven, and when that's done, I flip it to run. The other switch is just a switch to hold it so nothing happens while I'm wiping off the condensation on the oven door. The power supply, the batteries, just plug into the side of the box in this jack. This connector goes to the small DC gear motor. This is for the programming device I use, which I'll demonstrate later. This plug goes to the stepper motor. This lead goes to the temperature probe, and the other lead goes to my sensor module, which clamps onto the oven itself. I'll explain that more later also. This is the inside of the box. I'll go through all the parts. This first part here is just a little 5-volt regulator that I use to convert the battery voltage 7.4 to around 8 volts to a reliable 5 volts to power the electronics. This chip is called an H-bridge. It's an interface to the small DC gear motor. It makes it easier to control the forward and reverse of the gear motor. Under this heatsink is the IC that I used to control the stepper motor. Could control it directly from the PIC, but this is a very handy controller. The reason I have the heatsink on there is because I am stretching the capabilities of that chip and I don't want it to overheat. This little piggyback board here, sometimes called creeping features, is what I added when I decided to use a thermocouple input so I could add the capability of programming the temperature for the oven. And it just required another little board, and I had to hardwire it in. And this is the PIC. It's a microchip microcontroller, a PIC 18F2520. More than enough capabilities to do what I'm doing with this circuit. These leads connected to this terminal strip go out to the LED sensors that are used to position the oven when it's tracking the sun. These leads go out to the stepper motor. This bundle of wires here go to the little programming box that I use to program the temperature that I desire to hold, and also that little box provides an awful lot of feedback information as to what's really going on. That's pretty much it for the insides of the box.